Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We are gonna, I guess, start debugging our code today. We've got some stuff we want to do regarding asset reloading, and we've implemented most of it. We really just now have to go through a little bit of plumbing and a little bit of debugging to make sure that everything works cleanly. The two things that we need to do are, one, finish writebacks, which we mostly did already, and then debug everything. The other thing that we're going to want to do, and after we get this working, is we're going to want to add something to store, for lack of a better term, some edit data. And what I mean by that is, if you take a look at how we implemented the sort of on-demand asset packing, and we kind of go through and take a look at it here. So if we take a look at how the asset packing stuff actually works here, when we go into the check for art changes stuff, right? When we're loading these things in, whenever we find a PNG, we find one of these like little match guys, which keeps stored in the header files. Well, I shouldn't say in the header files. In memory, it keeps stored what the asset, what the assets were that these PNGs represented, right? So we have this asset indices array here that says, like, oh, for each tile in like the group of tiles that this PNG had, here's the assets that those corresponded to when I imported it last time. These will not get saved anywhere. So when you run the game, you import all these PNGs, you close the game down, you launch the game again, they'll all be gone, right? And we don't want them to be gone, we want them to remain, because if they remain, then what will happen is we will be able to prevent the asset file from growing unnecessarily, right? Every time we launch the game, we would re-import all the new assets again, because we would not know that we'd imported them before, and we wouldn't know when they changed which assets to rewrite, because all that data, the file date and the asset indices, has gotten lost. So what we can do is we can write this data out to a separate file that's just like a little cache file that sits in the directory along with the game, and just says, hey, here's all the stuff that I imported on this machine. When you launch the game again, you just load that in, and you prime your asset source file hash table with the information from that file. That then prevents any future accidental over importing, basically, like bringing in PNGs that you already knew about but just only happened on a previous run of the program. So we need to save that out, and we need to finish the write modifications to HHA part of things. But we don't actually need to do that part yet, because that's just about making subsequent runs of the game work properly, right? And so for subsequent runs of the games to work properly, we'll take care of that. For right now, we just want it to import assets properly for one run of the game, and so that's what we want to do here. And the two things we need to do for that are inside write modifications to HHA. When we go through the assets, we need to pull the information out, right? And pulling the information out of the assets to write it back to the file is what we're going to do right now. And then the other thing that we need to do is we need to decide on some tags to give these assets. Right now, we just don't. So when they come in, they'll never be used. We will import them correctly, but they will have no tags attached to them, so no one will ever find them for any purpose. You won't be able to use these assets, right? So we need to find some way to give them some tags. We can give them some test tags to start with, or whatever we want. So that's easy enough, but we need to eventually get to a place where we have some idea of what tags we're going to put on there, right? Okay. So if we come down here and we loop through the asset indexes, here are the assets themselves. Oops. Or they should have been. Where is my struct asset? There it is. So each asset has the information we actually want in it, right? It's got like which asset it was in the file, what file index it was in, and what the HHA was, and all that sort of stuff, right? So what we want to do here is we have, because we're running, the game has all of the assets known to it across every HHA. What we want to do is look for the ones that pertain to this HHA specifically. So for each asset, we want to check to see if the file index in this asset is equal to the file index that we're actually looking for, right? If it is, then we go ahead and write it out, and if it's not, we skip it, right? So in both cases, we're going to be doing something that looks like this. Put that over here, and that over here. So in both cases, we're going to be looking to see if this asset is one that we actually should process. If the asset is one that we should process, then what we know is we've got, to make space for it in the file. So this file is going to have one more asset than it had before because we found a new one. And then for the tag count, we just need to know how many tags this thing had. Now in the HHA file, I believe that, I'm sorry, not the HHA file, in the HHA struct, I guess I should say, we actually have a sort of a list here that says, hey, this is the first tag that I use, and this is the last tag that I use, right? So we kind of know how many tags we're going to need for this particular asset because the HHA asset itself says that information, right? So it's pretty easy for us to figure out what that should be. So what I want to do here is say, okay, this asset's, this tag count is going to add however much this asset says that it needs. Maybe I could do, well, no, I'll just do it here. So that's, an example of grabbing out the range, adding the tag count in. We now have the asset count and the tag count, so we're ready to write it out. Similarly, then when we get here, there's not a lot of, there's really not much to this, right? We can just write the HHA out directly, and off we go. So in this case, we know that we've got this source asset. We then know that it's matching the file index that we're trying to write out. So what I want to do now is go, okay, we've got a target HHA asset, right? That's the destination asset. And what we could probably do here is also say, hey, let's just start at the front of the asset array, right? And let's also start, let's do a dest type at the asset types, right? So with these here, what we could do is just write these things out incrementally. Now, because we're writing out the HHA asset, the asset type thing here, because this is a little bit weird, I suppose what we want to do in this case is keep track of the asset index like in the file. So maybe we don't really have to do that. We can just do it this way. And so once we grab that piece of information and we then have a destination to write into, we can say what the type ID of this asset was. We can say what the first asset index was. We can say what one past last asset index was, and so on, right? And it's just going to be, sorry, this is just type. It's just going to be whatever the asset index was in the file. And the type ID, right, is just whatever this asset was supposed to be, whatever type this asset was supposed to be. So if we go back into Handmade Asset in here, one of the things that's a little bit of a problem is we don't really record that information anywhere. So the asset memory header has the asset type in it, but we really don't record it anywhere else, if that makes sense. I'm not 100% sure. Yeah, like we don't store that data anywhere at the moment, and so our ability to write it out is kind of compromised. And I feel like we're going to probably have to augment Like, I feel like we're probably going to have to augment that structure to say which one it is. Now, we could get around this if we wanted to. By using this linked list. I'm not sure necessarily why we wouldn't bother storing the type in there, but we could just not do that, right? So for example, if we wanted to, in here we could just say hey, here's all the asset types, right? The asset index, globally speaking, is just first asset of type for that type ID. And then we just know the type ID, right? So, yeah, I mean, we can get around storing the type ID because we actually sort of have it stored implicitly, but, you know, we may want to just store that in the actual structure now that we're doing updates, because it's not like it's a huge deal to keep that information. It's pretty minimal. So I'm not sure that's really a smart idea long term, but we don't need it for this, so I suppose, you know, I'll just say note. We loop through the type, the first asset of type lists here because we don't store the type ID. So, you know, not sure what we want to do about that. Anyway, what happened there? Handmade asset. Oops. Didn't mean to type an A in there. There we go. So yeah, moving on here, we have more work to do though, and again, this just gets down to the tag situation. So when we actually have a destination asset here, really the destination asset is just going to be whatever we had stored in the file for in the asset struct for its HHA. So we don't really have to do anything at the moment. And again, that's just because we stored the HHA asset information here, so we can copy it into the array like so, just directly. But it's a little misleading because it's not really going to be correct. And the reason for that is, like, we just kind of nerfed the tag array here. Like, it's not really correct. And so, I'm not sure how we really want to approach that going forward. For right now, I'm just going to say, okay, let's actually just write out the tags as if we were preserving them exactly the way they used to be, and we'll just go from there. So what we want to do there is say, well, we've got this tag array, and so I'm going to have a dest tag, I guess, that I write out here. Although I guess, again, we want to be able to refer to the index, so I guess I'll say tag index in file. Right? And what we'll do is we'll write out these tags one at a time, and I don't know if we skip the first tag in terms of when we actually read them in. I don't think we do. Yeah, I don't think we do. So when we read them in, we assume that the first tag is actually valid. We leave space for a null tag, and then we continue forward with the tag array. So when we're actually writing out one of these, what we want to do is just write out all the tags that we see. So we want to do a for I loop in here for like a tag index. The tag index needs to loop over the HHA that we're going to write out. So the first tag index and the one past last tag index, oops. So as we loop over the tags here, what we want to do is we want to take every individual tag that we see and we want to copy those tags into our tag array so that we have them all in a nice flat structure that will get written out, right? So what we do here is we say, well, we know that we have the tag index in the file that was the last one we wrote to. So if we take the tags array right into the next position, whatever the tag is that we see for this particular asset, we should be good to go. Now, where do we get the actual tags? Well, the actual tags come from, in Handmade asset, the game asset struct has all the tags in it, right? They're sitting here. So if we just look at the tag in question, that's the one we wanted, I think, right? So we're just pulling out the assets tags and off we go. Now, what I'm not quite sure about is I don't really know, I assume that when we took the HHA, we offset the HHA, right? So like here, just to double check, when we load in an HHA from the file and we assign them all, right? I'm assuming what we do is yeah. Oh, that's interesting. So actually, though, that does look like the first tag is skipped. So what am I saying when I said the first tag? I thought it looked like it was loading the tags. Oh, it's not loading the tags. It does skip the... Okay. I apologize. I apologize. I made a disgusting error. So I take it all back. So the first tag is in fact skipped, and that means we could zero struct tag 0, right? Although these are all getting cleared. I don't know that we really need to clear all these, to be honest, because we're going to write to them all. But, you know. Anyway, so when we write through here, and we write everything out, what we're going to find now is that all of the tags that we have are packed into the file. It looks like if it's a 0 tag, we don't want to write anything, but that's already the case, right? So because we're not gonna, it's going to be 0 and this is going to be 0, and so it's fine. So this should write out all the tags for us, and now once we have all that, we'll have the header, the tags, the asset types, and the assets. All of those things can now be written to the file, and that should conclude the updating of an HHA, right? So that's all good. Now, one thing we do need to check, and this is sort of a separate issue that's just about the platform layer and has nothing to do with anything else, is that the platform layer's ability to write to the file is predicated on having opened the file with the ability to write the file, right? Because the operating system maintains those handles. So when we have write data to file, don't ask me why this is not that. So when we have write data to file, what we need to be able to do is ensure that this handle that we actually created up above here has the authority to write in the first place. So what you can see is it's got two, well, I guess technically it has three. It has three sort of places where that comes into play. One is this, and that generic read handle, I'm sorry, that generic read flag is just telling the operating system that's what we plan to do with this handle. So if we left that as is, when we tried to write to this handle, it would tell us that we couldn't. The write would fail. And the reason is because we didn't ask for permission when we opened the handle. So what we really want is we want this to be opened with permission to write to the file as well. If we're actually, if it's actually the case that the handle, not sure how to say this. We want to have the option of doing this, I guess is what I would want to say. We want to have the option of saying that we want to write to the handle as well as read to, from the handle, right? So what we kind of need here is the ability to specify some information about what we're going to do. We sort of want to do something like this. we kind of want to start and we want to see what kind of a handle we're trying to make here. Is this something we plan to write to, or is this something we plan to read from, or both, right? And then we want to actually apply these things sensibly. One thing we could say here is something like this. You know, if we plan to write to this handle, right, then we know that the handle permissions have to be generic write enabled. If, you know, we plan to read from this handle, we'll fill those in a second, then we want generic read. Now, in terms of how we want to share access to the file, we probably will allow people to read from it at all times, because whether we're writing or reading from it or whatever, if someone else wants to look at the file, we don't care. We don't have any specific reason to prevent people from reading from it. We do, however, probably need to prevent people from writing to it, because if they wrote to it, it might change the file out from under us, and then we'd get really confused and crash and do all sorts of bad things, right? So we want to make sure that we're the only people accessing it. And if anyone's going to write to it, it's going to be us. So the other thing that we need to deal with is this open existing thing here. So what happens here is when we have handle creation, we need to tell the operating system what to do with the underlying file in the case where it exists and the case where it doesn't exist. So when we call create file W, we're going to pass a file name. That file name may be there, or that file name may not be there, right? And it depends on which of those it is. It depends what we might want to do with it. In the case where we're trying to read from a file, we want to open an existing file. We don't want to have the operating system create a file for us to read from, because that's not going to help, right? So when we open a file that's for reading only, we kind of want to just say open existing. Because if we're saying that it's for read, I'm going to put these in this order specifically. If we're saying it's for read, then we want to make sure that it exists. If, on the other hand, we plan to write to this file potentially, then it may be the case that we can just make one, because we might write to it, right? So in that case, we should probably say, hey, in addition to opening the file, if it's there, maybe we want to create it if it's not there. And so what you can see, this is a little bit different than if you're familiar with the C runtime library. It's a little bit different, the different modes that you have available. Those are like, you do parentheses like R plus and W and WB and all. Those are a little confusing and not always the best. So what we want to do, thankfully, is use the more direct Windows stuff. And that's what we're using right now. This is a lot more clear, right? And you can see what the modes are. There's create always, which means throw away anything that was there and make a new one. There's create new, which means create a new one, but if there was one there, just fail, so don't overwrite anything. There's open always, which means open the existing one if there was one there, but if there wasn't one there, make a new one and then open it. Open existing, which means if there's not one there, then fail, but if there is one there, open it. And then truncating existing means open a file that has to be there, but once you open it, get rid of all the contents, right? So pretty good, actually, set of flags here. Good on the old Win32 folks for that. And what we want in this case is an open always, right? Because we want to write to it, then what we want to do is open it if it's there. But if it's not there, then we just want to create one, right? So that's, I think, how we want to construct these. And from there, we can now figure out how to actually put some flags in place for that to occur in the platform layer itself. So when we have open file, which is this right here, the prototype for that should now have, in addition to the info to open, we also want to have like mode flags, right? And the mode flags are just going to be this for now. And so now what we can do is say, okay, those mode flags we can test. And what we can do is just use those mode flags to figure out which one of these we want to do. Then we can pass those like so. And off we go. So it's pretty straightforward, right? There's not a lot to it. That just allows us more expressivity in this. Now, one thing that we also have the ability to do now that I should mention is now that we've done sort of a more robust version of these things, we can probably just finish off this API here because it's pretty good. There's maybe one or two other things we might want to do. But we could probably get rid of a lot of this stuff, right? So this, I don't really know what get process state even does. What does that do? Oh, that's just for running external processes. Right. Never mind. So basically, like, we can get rid of free file memory, read entire file, and write entire file, because we can now just implement those inside the game as debug functions and not have to have the platform layer worry about them anymore, right? So I think what we want to do is something here which just says, you know, to do Casey, get rid of these eventually, make them just go through the open file, read data from file, write data to file, close file API. And like I said, it's not quite there yet because, you know, we haven't looked at doing that. But these would be pretty easy to replace now. And that gets the debug stuff down to just these. We don't really use this execute system command one anymore anyway. We were using that for some debug stuff where we were kind of playing around with it. So we don't even know if we really want that or will need that in the future. So we may be able to really slim this down eventually to the point where we're just looking at this stuff up here at the top. And this is a pretty good platform API now in terms of being pretty minimal, but getting most of the stuff that we actually need. Now, again, could it be refined? Yes. Will we refine it? Possibly. But it's just worth noting that, like, at some point you get to, when the API gets a little redundant, you might as well just consolidate it down, because every time we port to a new platform, we have to port all these functions. If we simplify them down to fewer functions, it makes porting to new platforms easier and more consistent, because more of the code lives in the shared part of the code base, which means that you have less platform variability as well, which is also, you know, a very good thing. All right. So let's see. I think we're all good here. We just want to pass now open file read, because this is only reading at the moment, and we'll switch it to open file write eventually. Now these will always be open file read because we don't write to the PNGs, for example. I think that was mode flags, not mode flag. And then one other thing we need to do, we just haven't done it yet, is Win32 close file. Where do I set the platform handle? We don't. Win32 open file. There it is. So we added a bunch of functions. Now that we're going to actually start running this stuff, we need to make sure that we actually set up these platform calls so that they can be accessed by the game. All right. So I think that's really it in terms of the writing stuff. I don't really think there's anything else we need to do. So now we should kind of start, we should we should start down the road of trying to actually put the assets into the game. And to do that, like I said, requires us now starting to work with the tags. Because basically everything in here is going through tags in one way or another. And so if we want to have the actual assets available to put them on these walls, or, you know, change with, you know, the sprites of the character or stuff like that, we need some way of setting up the tags so that those tags actually get used when the game is searching, you know, for art assets to use. So I'm going to borrow the same trick that I did for the assets themselves, and I'm just going to make it so that we can add tags to the system. Like so. When we look at max asset count here, let's see, here we go. I'm going to do the same thing that I did before. So I'm going to say that max tag count just equals assets tag count. And then I'm just going to bump it. And again, I think we're going to change the way we do this stuff eventually, because we can simplify those tags down. I think we can pull some of the complexity out of that, probably. We'll see. Depends on how we want to do it. But given that we sort of have that basic situation now, what we want to do here is just give ourselves a way to add the tags we already have just for testing purposes. So by doing that, we could, now that we have a reserve asset that uses headroom in the asset array, I can also do the same thing with reserve tag. So in here, what I would do is exactly the same thing I did with the assets, like so. But instead of reserving a single one at a time, since we know we typically want arrays of tags, I'm actually going to just have a tag count that gets passed in here. So what I'm going to do is say, well, if you could have reserved all of the tags that you asked for, don't ask me why this... oh, wait, no, it should be less. Never mind. Yes. There we go. I will just reserve all of them in bulk, right? So you tell me you want a certain number of tags. I give you back a block of that many tags, or 0 if there was no way to do so because we're out of tags. So now we can assign tags to any of these things that we want to assign tags to, but the problem that we have is now we've run out of stuff we know what to do, and we're into the place where we have to start making decisions. So the first thing I'm going to do is I'm just going to assign the old school tags in some kind of hacky way that just allows us to debug the asset importing itself. Because that will at least get us so that we can say that our PNG import path is now complete. And then what we can do is start on the next leg, which is putting the assets into the game that we have. And in doing that, the goal of that will be to figure out how these tags should work for once and for all. So that now we're just going to say this is the final way that tags are going to be specified, right? Okay. And again, my suspicion here is that really what we want to do is the tags are probably going to be streamlined down to correspond a little bit more with the asset, the way that the assets are set up. We'll probably just have a bunch of things that are sort of like constant tags in some way that's sort of like, I'm guessing it'll be like, the asset type tells us something about which, you know, group of things you are, and then the tags actually just tell us like which kind of grid square you were, and or something like this, and we just know exactly which ones to jump to. it's hard to say, but I don't know. I'm thinking that we're going to have a simpler way of doing it just because now we're coming in with sprite sheets in a pretty straightforward way. All right. So I think that's it. So I'm going to go ahead and just see what the easiest way is for me to add something in here. So if we go into the entity system, I should say placeholder entity system. Obviously, we don't really do much with entities at the moment. But if we go into the stuff that does entities here, and I actually just create something that, you know, like we don't have, the hero doesn't have a hand, right? The hero doesn't have a hand yet. So let's suppose I went into the handmade asset stuff and I added the notion that there is a hand, right? So in the table of assets, I have a thing called asset hand, and asset hand is a new thing that you can have, right? Well, we know that we have one of those. Actually, we have two of them, I think, in the test assets that Anna sent us. We have three. We have like a flaming paw thing. We have an actual glove, and we have a skeleton hand. Right? So we know we already have everything that we need out of these. We already have the notion of what this is. It has 4 different directions, right? And I think it's just a base item template. So I think I don't really know how the hand files are set up. There is no hand template file. I should ask what that's going to be. Let me actually send a mail real quick, just so we know, because I don't want to forget. Okay. So when we load in one of these hand files, we can assign it the new asset hand type ID, and then we can use the existing tags we have, which is facing direction, right? We can take the facing direction and assign it properly to correspond with these directions, right? And that one's a little bit harder to see, but it's right, up, left, down, just going around the circle exactly as we would expect. So if I wanted to do that, what I could do is say, all right, let's start by only importing hands, because we don't want to waste our time importing everything because we don't have tags for everything and we don't know how it wants to be imported yet. We're just going to do hands, and we're going to see how that works and debug with just the hands. So when we come through here, what I want to do is filter out anything that isn't a hand file. Now, what you see is we've already sort of done this, which is that this pieces here, this part, that pieces array should have just the names separated by underscores. So if the first name is hand, that's a hand file, and if the first name is something else, it's not. So that gives us a pretty straightforward way of dealing with this, right? Okay. So what I can do is in here, I can sort of start by saying, where's those little pieces things? There it is. I can just test for strings being equal in the pieces. I can say, if strings are equal, pieces 0, what is it? Hand, then do this. And that will tell me whether or not we have one that we actually want to process. All the rest of them, I will simply skip, right? and that'll be that. So let's go ahead and do that. I don't know that we have one of these for a counted string. Okay, so we do. So if we want to, right, take one of these things here, we can actually make a little simple utility function. And all we're doing here is just calling a function we already have. And we're going to pass the stuff that we have here, right? So we know we've got a count, like so, and then we're going to return it. Similarly, we can also do this way, because we have this one too. So we can do the same thing that way, right? I think I claim aha. There we go. That was a U8 pointer, and it wants a char star. It's fair enough. All right. So now what we should be able to do is call that change function. And what I'm going to do is in Handmade asset, when we do, I'm gonna put this into the header file so we can call it whenever we want here, like so. What I want to do is I want to check for art changes once we load these files. Now, what I'm going to do is when we start up the game here, right, I'm not going to bother updating existing files yet. What I'm going to do instead is I'm just going to have a dummy file that we use for appending new assets to, and we're just going to start there. So we're just going to start simple. So I'm going to do check for art changes here, and what should happen is nothing, because this won't be set to anything, right? So what I should be able to do, got the return value there. Compiler doesn't warn you on, the Visual Studio compiler doesn't warn you on a missing return value if you never call the function. I don't necessarily know why. It may be because of template things. I'm not sure. Sometimes to support like template-based stuff, they have to do things like don't require a return value if the function has never been called, because if the function is never called, then it won't have had to be instantiated, which means, you know, blah, blah, you know. It may actually be a requirement for all I know. I don't follow that stuff anymore. But it may actually be a requirement, so who knows. But point being, typically the compiler on Windows will not warn you about a missing return value till someone calls the actual function. Whether that's just because it doesn't bother looking at the function, or whether that's because it's actually required not to do that, I don't know. So that's sort of a separate discussion. But either way, it doesn't. So that's all that was right there, is kind of reminding us. So now if we set a breakpoint there, we should be able to run the game. We should check for art changes. And what should happen is, since there's nowhere to append new data to, it should just skip, right? And so our game should run basically the same way that it was running before. Oops. We still have to fix that weird. We have some camera bugginess things there where it will like give us bogus values. I don't know if you know that. If we wait too long, like there's a, yeah, it's just a stupid bug. But anyway, that has nothing to do with checking for art changes. So when we do our check for art changes there, you know, we should probably just debug that, since I now can do it pretty easily. It's pretty simple. I think it's just the way the camera updates is, and the way the frame update is just kind of a little bit busted. So if I come in here, let me just take a look. Game input, oops, put So do you see this DT for frame? It's like 14 seconds, right? What we want to do is we never want to run the game forward 14 seconds, because if you pass a high enough floating point value in there, no matter what we do, things will probably blow up, right? Similarly, if you pass too small of a value there, things would probably blow up because we'd run out of precision at the low end. So what we probably should do, just in general, is we should have that capped. Now, we should also fix our camera code, because there's no reason for the camera code to be that bad. But we don't really want to do that right now, right? That should wait for when we're actually doing some finalization of the camera code. But what I want to do here is say, okay, if we have the DT for frame input, we want to cap it. All right. So what I want to do is say, all right, if input DT for frame, and I guess, you know, I can also look a little bit here to see who else uses it. But if the DT for frame is going to be greater than, let's say, you know, I don't know, 100 milliseconds, then that's the slowest we will ever run. And if it's less than 1 millisecond, that's like the fastest we'll ever run, right? And so, you know, it's hard to say what those should actually be. But what we want the platform layer to do is to keep those refresh rates within that rate. And if it can't, we should probably warn it, right? So the other thing we could do there is maybe have some kind of a warning. And maybe someday when we sort of do some code about that sort of stuff, we could add something in there, right? So now what I should be able to do is sit around waiting here for as long as I want to and do whatever I want. And then if I run the game, it should still work, right? And again, that's just there so that if something weird happens and the game like gets stalled for a minute, it doesn't come back and tell the game to do 1 minute's worth of updating, which will completely ruin everything, right? Because we simply have never architected the code to advance things by 1 minute. And so it would compute like really long trajectories for everything. And even if we made all of that code stable in the sense that it didn't crash, it just moved people to where they should be, the game would still be in a nonsensical state. So the design of it would suffer greatly from that, even if we made all the code 100% robust to it. So you kind of want to do that no matter how robust we ever make the code. We probably still need to fix that part. Okay, so moving on. We would like now to have the check for art changes code actually get run. And in order to do that, we now need to have an HHA that we're actually going to use, we're actually going to work with, right? Something an HHA that's set up specifically for this purpose, right? And so what I want to do is test to see if we're in the internal mode. And if we're in the internal mode, then I'm going to grab these HHA files for writing as well as reading, right? So when we come through this loop here and we're reading them in, I want to actually do an or write there in the case where we're going to be actually having, in the case where we're going to actually allow writing back to the files. So what I'm going to do here is say, yeah, let's just go ahead and specify we'll say open file read. We'll say if handmade oops, internal, open flags or equals to open file right. So what I would like to do here is I would like to just say, well, once we've ORed these two things together, now I'll just open all the files with that, because if we're assuming that we're going to allow writebacks, we can write back to any asset in the system, so off we go. What I'd also like to do now is say, well, we need to pick a file to append to, and it's tough to say what file we would want to append to, so we kind of need some rule here, right? If I go to Handmade data here, what I kind of want to do is I want to make an HHA that's for appending, and I want to have some way of indicating which one I want to append to, right? And I feel like I almost want like a command line flag or a switch or something, so when you run the game, you can tell it like I'm editing art assets, and here's where I want to put the new ones. You know what? No, I guess I don't want to do that. I think what I'd rather do is I think I would rather create a file, if I haven't seen one, that's called like new assets.hha, something like this. I mean, it seems like what I would like, you know? I'm just not sure how I want to do that specifically. I mean, one way is there's just always a file called like newassets.hha or something, and they all just get appended to that. And then if you want to lock down one HHA, you then just rename it to a new file name, right? And it will then create another new assets.hha where new assets would go. So, right? I mean, that seems fine. It's just, I'm just not sure. Yeah, I don't have a really strong opinion about this. I feel like there's a lot of options, but there's not a clear, like, right answer to me. I just need some way of knowing which one of these files should be accessed in that way. I guess maybe what I'll say is... I guess maybe what I'll say is that you can... Yeah, I'm just sorry, I'm just not feeling it. I'm not feeling an obvious right answer here, so I'm not sure. I mean, I guess I'll just say... The use case for this is, generally speaking, you run it on an artist machine, and they want to basically just make, they're just putting PNGs down, and you want to capture all those PNGs into an HHA, which you eventually would ship or something, right? But you really don't care because you can always rebuild it all from the PNGs anyway, so it's not like you really care what HHA it stuck them in. You can stick them in any HHA it actually wants to, because that has nothing to do with how you actually build the distribution HHAs. You could build them any way you want from the PNGs that get imported. So the HHAs are really just a cache, and you really just don't care. So I think what I'm going to say is, I'm just going to say, like, look, it creates a file, I guess, called like local HHA or something like that. And that's the one that it will write to in that case. So like this. You know what I mean? So we basically have like one local one that we just sort of have around, and we go from there. Seems reasonable to me, I guess. I don't know. I mean, another way to do this would be to say that that just automatically gets created somewhere else. Like, we could say, look, at startup, there always has to be one of those, and if there are, we go from there. So like we say, all right, we loop over these files. If Handmade internal is set, then we do this mumbo jumbo here. And when we have, when we do like looping over the file info, and we do platform open file and that sort of stuff, what we do is we check to see at the end of it all, if Handmade internal is set, then we do if strings are equal, and we test to see if this is local.hha, right? We can look at file info. I assume we have some name here that we can trust. It's called base name, I think, right? Yeah. So if we just look at the base name and it's local, then whatever the file index is that we have right now, that's the one that we're going to use. So I'm actually okay with that. And then if we want to, we can do something that creates one of those. And if we don't, we don't. So when we run this, it'll still skip this, right? But then in the Win32 Handmade directory at startup, if we wanted to, we could create one of those, right? So we could say, debug platform write entire file. You could just say like, yeah, write this file out if it doesn't exist, again, not really sure this is a great idea, but I'm just saying, like, You know what else we could do? Actually, now I think about it, I kind of like this even better. If you want one of these, you create one using some alternative method. So like maybe we take simple preprocessor here, and simple preprocessor normally, like here's the test asset builder. So maybe like we take test asset builder and say, well, maybe we should have one of these that writes an HHA out with nothing in it. So like we could do something like like this. Actually, you know what? So now I am actually getting a plan. Now I think I know what I actually want to do here. Okay. Okay, here's a proposal for you, because I haven't been feeling good about any of the options there. I just didn't like them. But now I think I have one. Let's just make a little utility that we can run, and we call it like HHA edit or something, right? Or HH edit dot CPP, right? Something like that. And then this thing just allows you to do stuff with HHAs, maybe, right? That actually seems pretty good to me. So, you know, we basically say if, you know, if arg count equals, yeah, this is really stupid. But it's just a basic command line utility that, you know, just uses C runtime library. It's standard, nothing weird going on, just basic stuff. We would say, look, if, you know, args1 was create or something, right? Then create one of these things. Maybe. Let's say. And like this will just let us do stuff. So maybe in the future we'll have things that can like merge two HHAs or dump HHAs or do whatever we want. So it seems reasonable, right? And so this could include the same stuff that we included here. In fact, I'll just grab this directly. And then I'll put that into the compile path for us. That should be about it. And then I'm happy camper, right? So then, yeah. So then I could add one of those to our MISC directory where we have like our batch files, you know? And so in here I could make an HHA edit.bat echo off w build HHA edit.exe pass all the stuff to it, right? And now it's in the path, so I can do stuff. And what I can do here is say, all right, if you pass minus create, then we'll make one of those. And we probably want to make sure it doesn't exist yet. So I might do like dest equals fopen file name read binary if dest, that's an error, right? So something like this maybe, so that I can do that, so that it won't overwrite a file. You would have to delete the file first just to make sure you're not accidentally overwriting something when you ask it to do one of these things. So just test to see if the file exists, and that's it, right? So then assuming that we can open one here, then what we want to do is just write an HHA header to it. We want the header to be blank because we don't want anything in it, right? So the only thing we want to set is the things that are required on an HHA header. So for example, magic value, and version, and everything else should be null because there's nothing else in the file. By the way, we figured out the awesomer way to do this, didn't we? When we did the PNG reader. Remember when we did the like... Oh, right. It was like crazy. You can just like put it in single quotes. So nuts. Anyway, that's so nuts. Sorry, I just wanted to remind myself that that was crazy, but I had never seen it before. So anyway, we need the magic value in the version, but we don't need anything else. That should just create one of them, right? So here, let me do HHA edit. If I do create, it still doesn't have enough arguments for it, so it tells us we don't want to have one. If I do foo.hha, and now I do a dir foo.hha, it should have created one of those. Well, and in theory, if I run it twice, it should tell me that it already exists. So then if I go to the data directory, and I want to make one of these for the local cache, I can just do HHA edit minus create local.hha, and now there is one. So now, in theory, if I did the rest of it right, it should actually have one that can write to now, although it looks like we get an assert here. So I'm not sure how this got in here since asset count for type is 0. Something's weird. I think maybe this was just there we go. Why is that? Let me take a look at the file info. I see that I am not in a debug build. That is just right out of the question, sir. Okay. Now I can actually look at stuff. So it says that so this stuff is all actually filled in. I'm not sure what it's complaining about, but I should probably look here to see what's going on when it initially loads the files. So we can determine what actually happened here. Which file is this, by the way? Fundex6. So here is my assumption. These are not properly guarded. So probably what's going on here is the tag count and the asset count are actually erroneous because you're not allowed to have 0. If that makes sense. So I'm not sure how that would have worked anyway, because it should have produced an extremely high number for these, because it should have been 0 minus 1 and 0 minus 1 in both of those cases. So I'm a little weirded out by that, but I'm just going to step through this and see what happened there, because that does seem a little strange. So we're loading test fonts. And we're loading test 3. And test 2. Test 1. And now local. Oh, so it basically just wrapped it produced -1. So I'm not sure exactly how I want to handle that. So it seems like maybe that argues that these should produce those properly. But I don't know. I kind of don't love the fact that that's how that works. So I don't know. For now, I think what I may do is say that we actually handle that case. But I don't quite love it because it's a little bit too much ifing going on there, and it's not great. Let's jump back to that. Yeah. So I think it was just the fact that those are subtracting 1 was probably the problem there. We now have a default HHA to append to, so this code can execute. And so now we can start to look at the situation as we had it before. So let's take a look at what our pieces array says. So you can see here we've got title, and you can see that the count of the string here tells us how many characters read. The debugger doesn't know that these are counted strings. It thinks they're null terminated strings, so that's why it says title screen, but it's actually just title, right? Because it says there's only 5 characters. So it's split it into title and screen, which is exactly what we want. It's not going to find one of those, so it's going to create one of these on, matches for it. But then it's going to punt. It's not going to actually find that because it doesn't have hand as the first thing. So you can see, again, we get obstacles orphanage, which is good, obstacles forest, item template, blah, 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 right? So it's going through everything like we wanted. Here we found an actual hand, one of these. So now we can actually look at what it's going to do. So it should match, and it does. So now we start our import. This allows us to open that file. This is the file in question, right? This platform thing here, okay, that's not what oh, yes it is. Those are wide characters, I believe, right? I thought handle platform should have had, that's why I'm an idiot. It's supposed to be file info platform. That's what I was looking for, right? So what was that thing? Here we go. There. So that's the actual file that it's going to be grabbing there, which is what we wanted. So that's good. So we come through here and we say, although, okay, never mind. So in here we loop through the file buffer stuff. We read in the data from the file, so that should get us the entire file. Hopefully there's no error on it, which we should probably check that, but we didn't. We match the file date and say, okay, now we've got the latest data. We go through update art packages. We start to read from the buffer that we were given, which is, as you can see, it's the constant of the ping. So we ask the PNG reader to read it. So there, the PNG reader did read it in. Here's all of our ping. That was the work we did before. Awesome. We go through process tiled import. Process tiled import comes through and says, all right, here's all of the tiles that we might want to look at. Let's go ahead and look at which one of them contain data. So I'm going to go ahead and jump till we get to one that does. So we've found one that contains data. And so now what we're going to do is we're going to initialize what we think the HHA asset should be. We should find that we don't have a backing store for this yet because it's the first time we've ever seen it. And we aren't storing backing stores to files yet anyway. So even if we had seen it before, this is a fresh run of the program, so it wouldn't find anything regardless. So we try to reserve the asset here. So we come through and we say, well, all right, how many assets could we have? We have that many. How many do we have? Only that many, so we easily can. Let's say put it in this asset. We now have an asset index for it. We can go through and set all this information. Since we haven't seen it before, we're going to put it in this file, which is good. We can reserve data for it. This is how much data we need for one of the tiles, right? So we can set that information up, record the HHA now, and of course it doesn't have tags, which is the problem, so it won't be able to be seen. That's the part that we need to start working on. We have the asset indices here. We record the fact that the first tile has that asset index now. And then we want to write the data back, right? So we want to say, okay, write the data to the file. The offset should be just after the header, which is exactly where it is right now. So that's perfect. And then we want to write this data in. So now what we should see is we should see this file expand. This file is a 44-byte file. It should now go to a 4-megabyte file when this gets written out to it, right? Well, it hasn't gotten written back yet. So hopefully okay. I assume that means the handle's still open. Not sure how to really get any confirmation as to whether the write is pending or not. So it looks like that write failed, actually. All right, so let's try that again. Let's see what happened. So here we are. We check for, oh, it already has errors. So at some point, we actually just already got an error on that file before we ever tried to issue the write. All right, so let's take a look. Here's local. We issue a read. We issue a read. We're still fine. Okay. So let's come through here. Let's see which file we're on now. So that file is number 5. Oh, I'm not even looking at the file index. 5. So there's the file. It says there's no errors. So we come through here. We're going to issue a read. So that read doesn't work. Oh, and of course, it's the same reason, right? So do you see, this is why I was saying I don't like that ifing, because you have to guard against all of these -1s. And it's just not, it's not, you want to be in a situation where those just work, right? And we're definitely not in that situation. So I'm not sure what the best way is to get out of that. So I'm kind of just perpetuating a bad situation here by allowing those code paths to work. I'm just not sure what the right solution is to fix that. So what we really need to do here, right, is if we look at the tag array size, it's something that only gets used here. So, you know, what we're doing is basically saying, look, if the file header tag count is valid, then we go. Otherwise, we don't. And again, that's just, I don't really like it. The rest of these, I think, should work because they use differencing to tell what range they should use. But well, let's not count our chickens before they hatch. So we skip that one, and we have nothing to read, so I think we're fine. Yeah. So then we can jump down to here and see now if, yeah, now we can see whether we have errors on that file or not. But you can see why I didn't like the way that is, just error prone. So now we will actually issue this write, and looks like it worked okay. So now I should be able to see the file expand, but it might not because the file hasn't closed yet necessarily, right? So if we do a dir on this, the local HHA against, it might not actually be updated. And so we may have to wait until we close down to actually see the results of that flush out, but we'll see. Okay. We should also close these file handles now. Well, I'm just going to let this run to completion, pulling out all of the hand data, which it did, right? And then I'm going to just close. So that will close all of the file handles for us. And now our local HHA has 50 megs of information in it. And we know that each of those hand pieces was about 4 megabytes, right? Not about, exactly. So if we do 1024 by 1024 by 4, if we take 50 megabytes, right, and divide it out like so, we get 12.5, right? If we think about how many hands we should have, it was 12. So we're basically right on the money. In fact, if I put in this exact number, we have exactly 12 effectively, plus the overhead of like the header and stuff, right? So that's exactly how many hands we should have had. So we pulled in exactly the hands we wanted, everything was fine and dandy, and now our local HHA has that information in it, right? So now when we actually run that, those assets will be there, they just won't have any tags, so you will never know. But they're there. For whatever that's worth, right? All right. So I thought there was one other thing I wanted to do there. But I've forgotten. Can I exit? Quit? No. So I thought there was one other thing that I wanted to do there, but I cannot remember what it was, so that's not great. I guess whatever it was, when it rears its ugly head later, I'll remember, because I'll have a bug, and off we go. Anyway, so that all is reasonable now, right? And all of this stuff is getting updated to pretty much the way that I wanted it to, and we're all good. So we now have to do something with actually putting those tags into place. And what I want to do here is assigning asset types to these guys. Oh, that's what I wanted to do. That's what I wanted to do. Yes, 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 yes. Thankfully, I just remembered what it was. So when we come through here and we're going to look at one of these assets, we never assign the asset a type, right? So we want to pull out that code that we're using to assign types to assets, right? This code right here. We want that code to be used up here as well. So we need to know the type of the asset, and we need to be able to put the asset into that type list. So this should be a function, right, that does this. And we should make sure that we would ideally want to check to make sure that the asset had never been this type before or something as well, but we want to make sure it's not already in the list, but there's not a lot we can do about that. We can assert that it doesn't have a next of type field, but yeah, I don't know. I mean, that's about all we can do, right? That's not conclusive, because it could just be the last in the list, and then it would still have that set. So again, the type stuff probably should be done a little bit differently than this, but we'll keep going with this for now. One thing at a time. So if we have an asset, we just say this is the asset, and then we need to say what the new type should be, right? And then so in here, it would just be, hey, okay, and I guess we need asset index here. Now we know we've set it. I need a thing here to say that, you know, and I guess actually I can do it just like this. No, I can't. I lied. So if I take that list, I can then say, okay, yeah, make sure we don't already have one of those, and then set it to whatever's in here, right? So if I do that, then I can do set asset type here, and I can pass the assets, and I can pass the asset index, right? So when we're grabbing this one, I can say that global asset index has to be this type ID, right? Then I can get rid of those, and now I have a function that can set the type ID of an asset outside of that context, because we're going to want to do it down here as well. So what I want to do is I want to, in here, I want to call that thing to set the asset type, right? And so when we come down here, if we reserve a new asset, then what we want to do is we want to set that asset's type when we reserve it to this type ID, right? And I could actually do it this way. So what we need now is we need an understanding of what the type ID actually is for this asset. And in order to do that, we need some kind of a coding in the system for so that when we're like getting these tiles out, we understand that. So this now becomes the tag problem, the asset type problem, the tag problem. So I'm gonna call this import grid tags or something. And I'm just going to say, all right, there's an asset type ID for each row. And then there's like some tags or something for each row and column, right? Trying to think of how that should work here, but you know, for now we'll just say, okay, import grid tags, and you know what, we'll just do one tag. Let me grab out an asset tag thing here. Where's our tags? Should be here somewhere. Tag ID. So it's just ID value, right? So if we imagine we just have like some HHA tag, and here we've got, so when it does this import, right, and it's looping over these things, the X count, the Y count, and the, you know, the X count max and all that stuff. What we want to do, since these are now kind of linked together, right? We probably want to just define a grid max for this, like an import grid max or something, right? And then that'll just be so this will correspond the same way, so you can index them both. And here's the tags, right? And what I need to do, I probably should do import grid tag or something like that. What I probably should do is say, all right, here's the type ID. I'll just make it so that it can be for everything. Here's the tags. Here's the tag count, right? And then I'll just say import grid tag, and we have tags. That's how many we have, right? So then when we come through here, we can just say, look, you've got to give this thing an import grid tag so it knows where to get its tags from. So when you interpret this source file, I want you to use this. Then when we come through, we know what the type ID is because it corresponds to the X and Y count. So I can then say, you know, maybe this is grid tag array, and then I can say this is grid tags. I'll just fluff that up into our structs here. Okay. And so in here, we'll just look at what the tags are for this particular one. And so again, we said it's YX. So in this case, we want to put the Y index and then the X index, right? So when we get those tags out, now we can assign a different type ID to each one of those, right? So each tile in the grid can get its own type. And then similarly, when we actually go to define the tags, we can do the same thing there. And what we could do if we wanted to is actually just set these based on some stuff that we sort of prefabricatedly made, so we don't have to copy them either. They could just be in the tag array. So we could say like, hey, first tag index, one past last tag index, like that. And then what we could do is just go, oh, so when we set one of these, we overwrite the tag array. So the HHA asset first tag index equals the grid tags first tag index. Like so. And off we go. So yeah. Keep going here. What is the question? Yeah, this is set type ID. That's an ampersand. Oh. No, it's not. And then all we really would need here is to actually assign some of these, right? So when we do our update asset package from ping, now again, same deal. We can just pass in the tag array that we expect to use, like so. And what we need now is something to pass here, right? And that's really what we're going to do next weekend, I think, right? We'll just say that we're going to pass that, and that would be it, right? And what we want to do here eventually is just say like, all right, we want to actually set these tags to something useful. So let's suppose we were going to do it and so in that case, we would say, all right, the tags are going to be, the type ID is asset hand. the first tag index equals something here. And the one past last tag index equals, and you know what, let me just go ahead and grab this out here. So the type ID equals asset hand, one pass, the first tag index and the one pass last tag index, right? These we need to set to some tags that actually mean something. And so what we would want to do here is when we're doing this import grid, we only want to do the first row. Everything else we want to be zeroed out, right? And so we could actually check for that zero out a little bit earlier on too. So what I want to do here is say, all right, the x index had better be 0. And we just, at the moment, we won't do anything for the other ones, right? And when we go down here, we'll use the y index to determine which tag we should or should not be. Now, going back up here, I feel like that gives us a way to knock these out where we should skip ones that aren't allowed. And so what I'll do is I'll say if the min equals the max, when we come down here, I want to make sure that the grid tags type ID is actually valid, and if it's not, then I want to error out. I want to say bitmap found in, or maybe sprite found in tile that doesn't have, or found in what is required to be a blank tile, right? So we're just saying, hey, we saw something, but it's not in a place that there should be anything because we don't understand how to interpret something being there in the sprite sheet. So that's an error, right? Then what I can do is I can say, oh, hey, yeah, as far as the tag stuff is concerned, then what I'm going to do is I'm just going to temporarily, and I think, again, I said this will probably... I want to have tags here that are like just the 4 directional tags, and we'll just stick those in there. So like dir tag 4, right? So all I'm going to say is the first tag index is just the 4. It's going to be the 4 directional tags in a ring or whatever, and I'm only going to do it for things where the y index is less than 4. Right? So that's the entirety of it. And I don't know why I... keep making mistakes there. There we go. That's the entirety of it, and all we would need for this to work is, in fact, and we can just do this, is inside the, when we actually create what we're creating, I can at the end of this just reserve some tags for those basic types. So when we come in here, I can just say like, okay, right? So I can go through each of these. I can say that the dir tag index in question is going to be reserve tags, 1 tag. So that gets me back that particular tag. And then I can set that tag. I can set that tag to be the direction tag that I wanted it to be. So inside HHA, and I guess I don't really remember what these are set to, if they're 0 to 1 or what they were, so we'll have to take a look at that because it's been a long time. And so in here, we'll just do ID and value, right? So the ID of this particular tag is the HHA direction, or sorry, the tag direction, facing direction. And the value of the tag would just be tau32, and we would go up to the value of tau32, the portion of tau32 for each of the steps in the angle, right? So we would do f32 dir tag index times tau32, right? So we just like facing directions winding around the circle. So that actually gives us now actual tags to reserve there. This stuff has to actually be placed kind of more up where it can start to be accessed by anyone in the asset system. So there we go. And so now we should actually have labels and on the hand sprites, and they should actually be you should actually be able to find them. What that also means is that in theory anyway, we could add a part of the hero now that referenced one of them and it should work. So for example, here where we do asset glove and we put asset sword in here, we could instead put asset hand in here, right? And that should now be able to find it. It won't actually find it in this case because because we didn't import the things with the type IDs yet. And I believe this asset count will be missing the assets we imported, right? Yeah, it will. Because those assets that we imported did not actually have types assigned to them, which we have to fix now. So now we should be able to test the entire process. What I can do is delete this local.hha file, right? Use HHA edit to create a bare one. And in theory now, when we actually run the import, those things that get imported should be tagged with actual information. Now, don't quote me on that because, well, there it is, right? So it actually was. However, it looks like we have our RGBs reversed there. So I think we're not doing the RGB flip because it looks like we store our Handmade Hero assets in the opposite order, in RGB order, right? But it all worked, right? So those are now loaded on the fly and integrated in. I mean, surprising, right? But it works. Now, we probably aren't quite done yet, right? Because on reload, like, if we didn't get all that stuff right, on reload it won't work. So we probably aren't really out of the woods yet, right? Yeah, right. You can see, like, these assets aren't probably getting loaded. So we didn't correctly rewrite the counts in the file or something, right? So that's our job for next week, but we're almost there. So I'm going to go ahead and delete that. And if the HHA isn't there, we should still run properly. Like when I run the file here, it shouldn't do anything, right? Because it doesn't find that extra file. So we basically did it. We now have asset reloading in place. We'll be able to refine it over the next few weeks, and we'll put all our assets in and have a little party. So there you go. I've been looking into existing approaches to assign items to cells for clustered shading. Okay. That sounds like it's pretty off topic, but okay. It's game development. I've already implemented 2 of them, but now I'd like to try an ID-based approach. They mentioned in their SIGGRAPH slides that an item shape can be an OBB or a frustum, and they test its planes against the cells in clip space. Since a cell will simply be an ABB there, I should really improve my math knowledge skills, but I currently don't know how to do this. Can you point me in the right direction? So I guess what I'd say is, if your question is just what does an ABB in clip space mean, we actually did this in Handmade Hero. So if you remember, when we do the projection, so when we do the perspective transform stuff, remember we make the matrix and we have a projection matrix that is what's, makes perspective foreshortening work. So what happens with that is when you have done your matrix multiply, to put your objects into when you've done your matrix multiply, you have your matrix, which includes the projection part. It's going to put the amount of perspective divide that should happen into the W coordinate of the resulting vector, right? So a vector comes in with a W coordinate, usually the W coordinate is 1. It goes out with a W coordinate that's actually a value that will get, everything will get divided by that value, right? Well, when you do that transform, that multiplication, you now have one additional space. Once you've divided by W, right, you have made everything perspective foreshortened. That's what the divide by W does. But before you've done the divide by W, you actually have another space that you've transformed things into. So if you go and look, hopefully there's an article about this somewhere. I'm just kind of hoping, here we go. Oh man, that's not, I mean, this isn't what I was hoping for, like maybe some a little bit more than that, but okay. So that was useless. Let me try explaining something again. And I'll use the whiteboard this time. I was kind of hoping for some diagrams there, but doesn't look like it's going to happen. All right. So suppose that I take a look at what's going to happen to all of my coordinates throughout the 3D pipeline, right? And again, this happens in Handmade Hero. So this is not something that's like just only for high-end 3D or anything. It's everywhere. Anytime you have anything 3D at all, you're doing this. So we have a matrix, right? And we know that there's a 3x3 upper component of the matrix. That's the rotation. And it also has scaling and so on. Rotation, scale, and shear all happens up in here, right? Then we know we sort of have nothing in the rest of the 4x4 if all we're doing is manipulating an object with rotations and scaling, right? If we want to add translation, then we end up with a vector here where this becomes the tx, ty, tz, right? That moves things around. And remember, in Handmade Hero, we went over why all this is true as well. So don't just think this way. Actually go learn this if you don't, or if you didn't watch the Handmade Hero. I explained how this matrix actually does its job as well. Okay, but then we also have additional elements down here that can be used for perspective projection. Why can these be used for perspective projection? Well, when a vector comes in, it comes in as xyzw. Usually w is set to 1. It can also be set for 0 if this thing is just a direction and doesn't want to have movement applied to it, right? But it's usually set to 1. So what ends up happening is this bottom row can move things into the W coordinate based on things like the Z coordinate. For example, if I put a 1 here and a 0 here, all of a sudden what I've done is when this matrix multiply happens, the W coordinate will end up equaling Z, right? And if I then furthermore create more sophisticated things in here, I can move Z with an offset in there. I can move Z with other things, right? I can do whatever I want. So I will end up creating a vector that has a transformed x, y, and z the way that I want to for my world coordinates, my z buffer, and all these other things, and then a w that's proportional to z somehow. And it depends on how I'm trying to build my matrix, but I'm going to have something proportional to z somehow, right? So when I do this matrix multiply, if this right here is my entire transform matrix M, right? And this up here is my input point P, and this here is my output point P prime, you know, I've got P prime equals matrix times P, right? That's what I'm doing. This action right here, this very simple equation, doing that. Well, this is my input space. It's where I'm storing my points. This is the transform that includes the camera transform, possibly the world space transform to move the object somewhere as well, right? And the perspective projection. That perspective projection means that this, right, P prime, is now in sort of a perspective space. Now, it hasn't actually had perspective applied yet. Why? Because we have not divided by W. Remember your similar triangles. Again, we went over all this on Handmade Hero. Remember your similar triangles. Here is the screen. Here is some point in the world. We are projecting that point down onto the screen. Those similar triangles, here this right triangle here, that divide, that perspective divide is what's giving us the foreshortening so that things that are further away project onto smaller spaces on the screen, right? This is much bigger than this, but it projects to the same point. Another point out here that's actually higher than this point projects to a point that's lower on the screen than this point, right? That's what gives us that shrinking effect as it moves away. That's what makes a perspective projection and not an orthographic one. So when we do this, we have a new space that we've created. It's not yet screen space because we haven't divided by W. We haven't actually projected. We're just in sort of a new space that's ready for projection. And that's what we call clip coordinates. Now, why do we call them clip coordinates? We call them clip coordinates because if you were to divide by W before clipping, everything blows up. Why? Sometimes W may be very close to 0. What happens when something is like right next to the eye, right? It's unstable. So we must clip out everything on the near side of the near clip plane before dividing by W, or all hell will break loose, numerically. So these are called clip coordinates because we clip in them. Now, because we have done a bunch of work to put these things into clip coordinates, and we've multiplied and all of the components to shift them into the camera space and blah, 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 right? There are operations that you may wish to do here that are easier done in the clip space than in other spaces. Now, why is that? Well, it's because all of our coordinates have been scaled around and modified by this matrix to fit into the region we're going to view. So clip space is basically the view frustum. We've mapped everything into a unit cube inside the view frustum, and we've made sure all of our coordinates have been multiplied, stretched, warped, compressed, pulled back, moved, slid, so that the things we actually want to view fall into a very specific space, right, in between the near and the far clip planes. And if we looked at this sort of projection sort of head on, so here's the eye and we're sort of looking down at it, we've made it so that things fall between 0 and 1 in X and Y as well. So what happens when we make everything be between -1 and 1, or 0 and 1, depending on how you're set up your transform. Let's say -1 to 1 in all cases, right? Well, if everything we're going to be able to see falls between -1 and 1 in x, y, and z, because we've stretched, pulled, and squished them all in there, and then what we're about to do is divide by w to make everything go like that, right? Well, instead of doing this before the transform where everything's in world space and it's all confusing and weird, like, you know, angled planes, and instead of doing it after, when we've divided by w and everything has gone back to all wacky planes, right? Why not start doing some operations in clip space where any individual cell is a regular rectangular tile? So if I want to, once I've done that transform, I've effectively taken this clip space and I've turned it into just a rectangle, because I already stretched everything out and warped it so that it fits into this unit just right. You know what I'm saying? So if you look at what's actually happening here in terms of the math, that's not what I wanted. So here's that perspective projection, right? And what you can see here, right, is that we've got the forward projection matrix here. And you can kind of see that the action that's going to be taken when we the action that's going to be taken when we actually, you know, pull these things through, you can see that we actually even do work to prep the z coordinate so that it falls between -1 and 1, right? And then the same thing happens to all of our x coordinates, right? So what we do with all of them is we make sure that all of them are corrected by like the aspect ratio and the focal length of our lens, right? So that they all get squished properly. So once we do this transform, we've preconditioned all of our coordinates for clipping. So what people are saying when they say do this in clip space, what they're trying to say is the particular operation that they want to do can just be most efficiently handled right after you do that transform, but before you actually turn things into device coordinates by like dividing by w and stretching to the screen size and stuff like that. Does that help? Is the warning in the C-time code supposed to be taken lightly? No, it is not supposed to be taken lightly. It is supposed to say that I absolutely do not warrant that it has been tested or debugged. So it's entirely, you know, your problem if something wrong happens. You should inspect it and see if you believe that it will work the way that you're using it. And if you are confident that it does, you can go ahead and do so at your own risk. If you are not, you shouldn't use it. I see that transient state has only 4 tasks with memory, and game uses much more threads, so the threads may sit there without work because you can only submit at most 4 such tasks per frame to queue. Isn't 4 tasks a bit low, or am I missing something here? Yeah, so what you may be missing there is that tasks with memory are very special. We don't actually use those for very many things. They're usually used for stuff like background loading that doesn't really require, and that we don't really want many threads working on. So actually, we spin up a lot more work that doesn't use memory in that way. You can actually see this happening if you look inside the profiler. So for example, inside here, if you look at the thread view, you can see that we actually have a lot more than 4 threads running at a time anyways, right? So 1, 2, 3, 4, 5, 6, 7 here are running and doing like lighting calculations. So we typically want lots of threads available for doing work. We don't necessarily want a lot of threads doing work and using memory. Psychomaniac TV, thanks for answering. The way I understand their slides is they have a convex shape defined by its boundary planes, either a 6-plane OBB or a 5-plane frustum, and they test it against an ABB in clip space. The AABB is already in clip space, and the planes come from world space. I have no idea how to test for intersection in clip space. What even happens to the planes when they are transformed? Well, I'd have to think if there's any shortcuts for doing... I mean, I don't really know exactly what they're doing since I don't know what you're referring to. But if you want to transform a plane, you can transform a plane just the same way that you would transform anything else, right? So a plane, fundamentally speaking, can be defined, for example, by a point and a normal. You could then transform the point and the normal into clip space. And that would be the correct plane, right? So the problem that you will have is that there's nuance involved in transforming things like normals by matrices that are non-orthogonal. So inverse transpose is actually the matrix that transforms normals. So if you just want the simple solution, probably the easiest way to do it if you didn't want to go learn the math is take 3 points on the plane, transform the 3 points, and reconstruct the plane. Because that's foolproof. Points always transform properly through the projection matrix. You don't have to know any math to do that. You can just put them through it. Then take those 3 points, subtract them, and generate the normal, and then you've got the plane, right? So I could go into a lot of other math about how you could do this more efficiently, but that's a pretty basic way you could do it. And depending on how much more math you want to go into, you can do things that are better than that, right? But the most straightforward way is to realize that since you already hopefully understand how to transform a point through the projection matrix, you can always turn a plane into 3 points, transform them, and turn it back, right? So it's pretty straightforward to lean on that, and then you don't have to worry about the other math minutia, if that makes sense. Hopefully it does. I mean, in case that part wasn't clear, you know, so a plane, let's say that you know you can transform a point, but you don't know how to transform a plane, right? You don't know, and you don't want to think about it, right? Well, a plane is just 3 points, right? For any plane in the world, I can just take 3 points on that plane, and now I have points defining the plane, right? So if I transform those 3 points through some matrix, I'll get 3 other points that are the new transform points. I can now reconstruct the plane by just taking the cross product of the 2 legs of the plane, right? So if here's P1, here's P2, and here's P0, right? P1 minus P0 cross P2 minus P0, right, is a normal for the plane. Make sense? It's not really the normal. It's hard to say the normal for the plane. It's the tangent to the plane. You don't care if it's normalized, right? So it's the tangent to the plane there, and now you know a point on the plane plus the normal, that's enough to test, right? That's the entirety of the information, right? Because if you want to get back to ax plus by plus cz plus d equals 0, which is the equation for a plane, well, a, b, and c are this, right? They are nx, ny, nz. They're a tangent to the plane. And the d value can always be found by simply taking the dot product of a point on the plane, which you have, P0, right? the dot product of that with a tangent to the plane equals your D value. So you can always reconstruct from 3 points a plane. All right, looks like we're done. I'm gonna close it down. All right, thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always do so by pre-ordering the game on handmadehero.org. It comes with a source code so you can play around with it and do your own experiments. We also have a watch page you can use to watch the series. It actually has some hot links at the bottom for things like joining the mailing list or exploring the forums or any of that stuff. And if you want to view any of our other Molly Rocket stuff, you can always click on the little Handmade Hero head, and there's links to all the rest of our sites there. We also have the Handmade Fund, which is a place you can go to contribute to community projects, such as the drawing program I was just using. We would like to start contributing more stuff to those, so if you want to donate to the community fund, we will find new places to send that money to. Right now we're funding Handmade Network and the annotated episode guide, which is a pretty cool thing you can use to search through old episodes of Handmade Hero. That's also on the watch page. So check those things out if you haven't already. I'll be back here next week. We're only doing one episode because I'll be off one of the days, but we will start next weekend actually pulling in art assets and trying to assign them to things in the world using the sort of reloading system that we've made now. So that should be fun, and we can debug all the stuff that we created these past couple weeks. It seems like the PNG loader is working fabulously, but that all of the stuff we put in for the updating the HHAs, you know, that probably could use some work, so we'll be doing that, and we'll go from there. So thanks everyone for joining me. See you here next week. Until then, have fun programming, and I'll catch everyone on the internet. Take it easy, everybody.